Have you ever just stopped and thought about the absolute beehive of activity happening inside your body right this second? I mean, it's basically a massive chemical factory, running millions of reactions that let you do everything from digest food to, well, to think. So let's pull back the curtain on this incredible, invisible world. Okay, so here's the big puzzle. If you tried to do most of these reactions in a lab, you'd need some serious heat or pretty harsh chemicals. And yet, our bodies are just humming along, doing all of this at a nice, stable 37 degrees Celsius. How is that even possible? How does this factory run so perfectly without, completely burning out? To really get the answer, we have to appreciate the size of the challenge first. Let's just call it the reaction problem. It's this fundamental hurdle that our bodies have to clear every single moment of every day. Seriously, think about it. Digesting that sandwich you had for lunch, building muscle after a workout, even just a thought flashing through your brain, it's all one giant, interconnected chain of chemical reactions. And for us to, live, these reactions have to happen super fast and all at normal body temperature. That's a huge ask, chemically speaking. So, what's nature's brilliant solution to this problem? Well, it hires a massive team of tiny, incredibly specialized workers. Let's meet the real heroes of this whole operation. These little workers are called enzymes. At its core, an enzyme is just a protein that acts as a biocatalyst. All that means is it makes a chemical reaction go way, way faster, but it doesn't get used up itself. And the key thing here is that they are total specialists. You've got one enzyme for one specific job. That's it. And what's really cool is how logically they're named. It's actually super simple. You just take the name of whatever the enzyme is working on, let's say the sugar maltose, and you just swap the ending to ASE, and boom, you get its enzyme, maltase. It's the enzyme that breaks down maltose. Pretty straightforward, right? So what's their secret? How do they work this magic? Well, it all comes down to something called activation energy. Think of it like the giant push you need to get a huge boulder to start rolling down a hill. What enzymes do is kind of genius. They basically build a much, much smaller hill. So the reaction needs way less of a push to get going. And we're not talking about a small change here. Just look at the numbers for breaking down regular old table sugar, sucrose. On its own, it takes 6.22 kilojoules of energy. But bring in its specific enzyme, sucrase, and that number just plummets all the way down to 2.15. That's a huge deal. The reaction becomes almost 3 times more energy efficient. That efficiency is the entire secret. It's how our bodies can perform all this ridiculously complex chemistry without breaking a sweat. It's literally what makes life possible. Okay, so our internal factory has this incredible workforce of enzymes. But hey, even the best workers in the world can't get the job done if they don't have the right tools and materials. So what are those essential ingredients they need? And this, of course, brings us to the other half of the equation. We're talking about vitamins. So what exactly is a vitamin? It's an organic compound that our body absolutely requires, usually in tiny amounts, to keep us healthy and growing properly. That word, required, is the whole point. We can't make most of them ourselves, so we have to get them from our diet. And if we don't, things can start to go wrong. The whole story behind them is actually pretty neat. They're called essential food factors for a reason. We can't make them. We have to get them from plants, or sometimes from the friendly bacteria living in our gut. And here's a fun bit of trivia. The original name was vitamine. It was a mashup of vital and amine, because the first ones they found had these things called amino groups. But later, when they realized most vitamins didn't have them, they just dropped the E. All right, so we're eating food with vitamins. What happens next? Our body can't just let them all float around randomly. It needs a system for managing and storing its supply. And this is where it gets really interesting, because it all comes down to one thing: solubility. Vitamins fall into 2 main groups. On the left here, you've got your fat-soluble ones, like A, D, E, and K. Because they dissolve in fat, our body can actually store them in our liver and fatty tissues. That means we don't necessarily need a fresh supply every single day. But then on the right, you have the water-soluble vitamins, like all the B vitamins and vitamin C. These dissolve in water, which means they get flushed out of our system pretty quickly. So for these, you've got to restock them regularly through your diet. So let's bring this all home. We've got our super efficient workers, the enzymes, and we've got our essential tools, the vitamins. The big takeaway here is how this all works together in a really delicate balancing act. And this is so important to remember. We all know that not getting enough vitamins is bad, but more is not automatically better. The source material is really clear on this. An excess of vitamins can actually be harmful. It's why you should never just start popping vitamin pills without talking to a doctor first. It's all about that balance. So really, when you boil it all down, it's a simple partnership. For that amazing factory inside you to run at its best, it needs both sides of the team. The efficient workers, which are the enzymes, and the right raw materials to work with, which are the vitamins. And that really brings us to the final thought. Your body is this incredibly complex, finely tuned factory. So the question I want to leave you with is this: are you giving it the high-quality tools and materials it needs to do its best work?